Hello and welcome to another session in physics. In this session, we'll be looking at the topic thermometer and its types. We'll also be looking at evaporation and boiling. But before that, let us review the previous lesson. Welcome back. At this point, I would like us to define what a thermometer is. A thermometer is an instrument. It is an instrument that we use to measure temperature. Thermometer is an instrument that we use to measure temperature. Remember, in our previous lesson, we've been talking about the differences heat and temperature. And we said that heat is a measure of the internal energy of molecules, whereas temperature is the degree of hotness or coldness of a body or an object. So the diagram here you see is what a thermometer looks like. Now, a thermometer is not just in its working, it works in tandem with what we call a thermometric substance. So what is a thermometric substance? Thermometric substances are materials that are used in a thermometer whose properties vary with a change in temperature. In other words, they are substances which change in proportion to temperature. So what we're trying to say is that thermometric substances react to a change in temperature. If temperature goes up, they react. If temperature comes down, they also react as well. It is this reaction that helps us to be able to take readings using a thermometer. We have many different kinds of thermometric substances, as you can see in the diagram here. They stay inside a thermometer. Sometimes they come in the form of fluids, but sometimes they can come in the form of solids. So let's take a look at some of them. At this table here, we're going to see a thermometer. We'll look at the thermometrical substance, and we'll look at the physical properties that make up this thermometer. It might interest you that the name of a thermometer is always based on the kind of thermometrical substance that it possesses. For instance, we have the first one, the liquid in glass thermometer. Liquid in glass thermometer simply means a thermometer that has liquid inside it, and that's it. So we have basically two kinds of liquids that we use as thermometrical substances. The first one is mercury, the second one is alcohol. So a thermometer that has mercury as its thermometric substance is called mercury in glass thermometer. Mercury in glass thermometer. On the other hand, a thermometer that has alcohol as its thermometric substance is called alcohol in glass thermometer. Now, the physical properties of both mercury and alcohol is that there is a change in their volume when there is a change in temperature. Generally, with liquids, when there is an increase in temperature, the volume of liquids increases. Liquids expand when there is an increase in temperature. But on the other hand too, when there is a drop or a dip in temperature, the liquids or the mercury and alcohol, they contract, they become congealed. That's why when you put water inside a fridge, the water turns to ice block. But that would not happen with mercury or alcohol, by the way. The second kind of thermometer we have is the constant volume gas thermometer. As the name implies, its thermometric substance is gas. And as we know from the gas laws, that of Charles and so on, they say that there is always a change in the pressure of the gas if there is a change in temperature. So temperature varies with pressure. So when there is an increase or a decrease in temperature, the pressure of the gas reacts likewise. And this helps us to take readings using a constant volume gas thermometer. We have the third kind of thermometer called a thermoelectric thermometer, which works on the principle that governs a thermocouple. We'll come to that later sometime in this term's lesson. Now, it makes use of two different metals, which are iron and copper, respectively. Iron and copper, when used together to construct a thermocouple, causes a potential difference to be generated due to a difference between the hot junction and the cold junction. So the hot terminal and the cold terminal as well. The same principle is used in thermometers, where due to a temperature difference, it could cause a change in difference, thereby enabling us to take readings using the thermoelectric thermometer. We also have the resistance thermometer. As the name implies, it makes use of a resistant block. In other words, we can call them resistors. So these resistors change with temperature. Sometimes with temperature they can get hot or they can get cold as well. And with these changes in them, we can use them to take readings using the resistant thermometer. We also have a bimetallic thermometer. A bimetallic thermometer is a thermometer that makes use of brass and iron as its thermometric substances. It is brass and iron because they are two dissimilar metals. They are not similar to each other. They work on the principle of the bimetallic strip used in pressing irons. In pressing irons, the bimetallic strip, due to expansion, can help us to increase or lower the temperature of the iron. Expansivity helps us to understand that when heat is applied to a body, that body tends to expand, especially when it comes to solids. When heat is applied to a body, that body will expand. And that is the principle that this bimetallic thermometer works on. Now, we want to see the advantages that mercury has as a thermometric substance. We don't use water as a thermometric substance, but we use mercury predominantly. So what are some of the advantages that mercury has as a thermometric substance? One of the advantages is that mercury does not wet glass. Mercury does not wet glass. When we say mercury does not wet glass, we mean mercury does not stick to glass. Unlike water. Water sticks to glass, but mercury does not stick to glass. The second advantage is that mercury responds quickly. Slight change in temperature. It is very volatile. It responds quickly to a slight change in temperature. The third one is that mercury does not vaporize quickly. It does not vaporize quickly. Because it does not vaporize quickly, it can be relied upon to be a thermometric substance, unlike it seems to evaporate at a very slight increase or change in temperature. Another reason because of why mercury is used as a thermometric substance is because mercury is opaque. Mercury is not transparent. Because mercury is opaque, it can be seen easily. It has a slight yellowish color, so it can be seen easily. The ability to see it easily makes it easier for us to take readings with very minimal level of inaccuracy. Another advantage of mercury is that it has a regular or uniform expansion. In other words, it expands uniformly. Now let's look at the disadvantages of mercury. Everything that has an advantage also has a disadvantage. The first one is that mercury is too expensive. It is not something that you just go to the market and then you buy it the same way you buy water. It is very expensive. And another disadvantage is that it cannot be used to measure very low temperatures, not used to measure very low temperatures. So basically say that it has a limit. It has a temperature limit that it can measure, and because of that it cannot be too reliable. As a matter of fact, the freezing point of mercury is minus 39 degrees Celsius. So if you're trying to measure anything below minus 39 degrees Celsius, mercury would not work, because at this temperature mercury will freeze, and when it becomes frozen, it becomes basically useless. Let's also look at the advantages of alcohol as a thermometric substance. One advantage is that it is less expensive. Less expensive than mercury. That is the first one. The second one is that it has a large expansion than mercury. Has a larger expansion than mercury. The other one is that it can be used to measure very low temperatures. Let me point out that alcohol expands 6 times more than mercury. Alcohol expands 6 times more than mercury. Now, the last one I mentioned is that it can be measure very low temperatures. Can measure very low temperatures. The reason for this is because alcohol has a very low freezing point. Yes, it can measure low temperature. If you can have access to ethanol, I would ask you to do this experiment and try to put it inside the fridge and see how long it takes with constant electricity supply when it will melt, and record the duration of time it took. Do the same with water and try to state your observation. As we did with mercury, alcohol also has its disadvantages as a thermometric substance. One of the disadvantages of alcohol as a thermometric substance is that it is not opaque. It is not opaque. It has no color. It is colorless. It is transparent, and so it can sometimes lead to inaccuracy when it comes to taking readings on a thermometer. Another one is that it vaporizes easily. It vaporizes easily, just like water. And the other one is that it wets glass. It wets glass, so that it sticks to the body of glass. And it also has an irregular expansion. It has an irregular expansion. And it also has a low boiling point of 78 degrees Celsius. So which means if you try to use it to measure a temperature that is above 78 degrees Celsius, it simply means that the alcohol is going to start evaporating. So it has a very low boiling point and cannot accommodate high temperatures. Thank you for joining us in this lesson. To refresh your memory on what we've just discussed, please take the test that will appear on your screen.